In this video, I solve a numerical question about maximum likelihood estimator of P. P is the parameter of binomial distribution. The binomial random variable has two parameters n and p. So in this question, we calculate maximum likelihood estimator of P and the random sample of m observation of x random variable drawn from binomial distribution. So here is the answer. It is given that random variable x follows binomial distribution with parameter n and p. The binomial distribution have the density function. So this is the density function for the binomial distribution ncx p power x q power n minus x, and the range of random variable x from 0, 1 to so on n, and it has two parameters n and p. Then by definition of likelihood function for a random sample of m observations, L of p, L represent the likelihood function. It is the abbreviation of likelihood. P is the parameter and it is equal to pi. Pi sign is used for multiplication. For addition we use sigma sign. And pi sign is used for multiplication. So by definition likelihood function I varies 1 to m, f of xi is the random variable, n and p are the parameters of the binomial distribution. So here we, in next equation we put the value of the binomial PDF of binomial distribution. So it is ncx p power x q power 1 minus n minus x. So q is also equal to 1 minus p. We write here as 1 minus p or q. P is the probability of success in binomial distribution and 1 minus p or q is the probability of failure. So now apply pi sign p power sum of xi, because xi means values from 1 to m, and these values are present in multiple shape, means p power x1, p power x2, so on p power xm. When we, as you know, when base are same, we can add a power, so it is equal to p power sum of xi. So similarly 1 minus p is equal to nm, because n is already present and it is multiplied by m times, so we write it as nm minus sum of xi, I varies 1 to m nc xi. So this is the, we solve the likelihood function. Next step to calculate maximum likelihood estimator, first step is to apply your PDF of the required distribution in the likelihood function by definition of likelihood function. When you calculate likelihood function, then next step is to take log, natural log. We always take natural log of e. So take log of e both sides of the equation. Here we use product rule of log. In product rule of multiple terms, apply log to each term and plus sign used among them. So take the log of e of each term and the sign to be used is plus, and apply power rule of the logarithm. Now here we apply the power rule of the logarithm, log of x power y log of x. So in power rule we multiply power with the log of the number. So log of e lp is equal to sum of xi log of ep plus nm minus sum of mxi log of 1 minus p plus I varies 1 to m log of e nc xi. Differentiating both sides. After applying the logarithm, the third step is to take derivative of the both sides with respect to p. because we want to calculate parameter p. So in this question we calculate MLE for parameter p. So apply differentiation function with respect to p. Partial log of e L of p over partial p is equal to partial over partial p sum of m xi log of ep plus partial over partial p nm minus sum of m xi log of 1 minus p, and similarly take the log of the next term. Using law of addition, in law of addition, as you know, we take the derivative of each term and plus sign is used. We take the derivative of each term, and we also use here constant multiple rule. What is constant multiple rule? In constant multiple rule we take constant outside the derivative. Take the constant like that, sum of m xi is the constant, because in this term there is no involvement of p term. We take the derivative with respect to p. So every term instead of p is considered to be constant, and it take outside the derivative. So this is the constant multiple rule. I take constant sum of m xi outside and partial over partial p log of ep plus. Similarly, in next term n minus m minus summation xi have no involvement of p, so this is considered to be constant and it take outside. So partial over partial p log of e1 minus p plus partial over partial p sum of m log of e n c xi. When take the derivative, sum of xi partial over partial p log of p, it is 1 over p, sum of m xi over p, and again the derivative of p partial p over partial p, it is equal to 1 plus nm minus sum of xi 1 over 1 minus p, take the again derivative partial over partial p 1 minus p. So the derivative of 1 is 0 and derivative of p is equal to minus 1. So here is minus 1, n m minus sum of xi over 1 minus p. So sum of m xi over p plus minus minus n m minus sum of xi over 1 minus p. Equating partial log of L of p over partial p is equal to 0, 0, sum of m xi over p minus n m minus sum of xi over 1 minus p. So take this minus term on the other side, it is positive. Sum of m xi over p n m minus sum of xi over 1 minus p. So by cross multiplication we get sum of m xi into 1 minus p p n m minus sum of xi. Multiply inside sum of xi minus p sum of xi n m p minus p sum of xi. Multiply p to both these terms. So sum of xi, this term take to the right side, nmp minus p sum of mxi plus p sum of mxi. Cut this minus and plus term with each other. It is sum of mxi is equal to nmp. So p sum of mxi, these two terms divide. When we take other side, it will be the divisor of sum of mxi. So 1 over n x bar is equal to sum of mxi over m. So put here x bar over n. So this is the maximum likelihood estimator of p. P is the probability of success, as we discussed at the start of the video. So this is the maximum likelihood estimator of p in the binomial distribution. If you want to see maximum likelihood estimator for Bernoulli distribution, difference between estimate and estimator, MCQs about inference, then click the link in front of your screen. If you like this video, then click on like and subscribe my channel Statisticians Club. Thanks for watching.